So hello everyone. A couple of weeks ago, Christian reached out and said, would you like to come give us a talk? We had this little room, just a few of my friends, and wow, it was good to see you all tonight. I hope my talk is interesting. So that's me without a beard, with my co-founder JR and another Cloudability, and that was taken at a board meeting in Denver. But I'd like to share a little bit about us, about Cloudability, about what we're thinking. We feel that there's some very deep historical forces at work in our industry, and I'd like to tell you all about it. So a little bit about Cloudability. We're here in Portland, Oregon, mostly, about 60 employees. And my background, I started my first business as a teenager writing video games, but after that failed, I went into Big Co in the 90s. And I'm not going to go into too much of the detail about this, but the 3 steps of my career, I feel, kind of left me in an unusual position to kind of view what's going on with a bit of context that is what I'm going to share here. So if you go back into the past and you look at the office workplace, it was pretty boring. And if you try and Google a photo of the office before 1990, as I did for this presentation, you will be surprised at the complete lack of photos. Every so often I meet someone, I like to put little pictures in my address book, and every so often I'll meet someone and I can't find a single photograph of them on the internet, and I find it very suspicious when that happens. The head of one of the large cloud efforts coming out of Europe was such a person. It's like they've gone out of their way to remove their photo from the internet, and it feels the same way for old work environments. And if you notice, if you look at these pictures, you'll notice that on almost none of the desks is a PC. And I'm actually old enough to remember this workplace. I remember some training videos from Pepsi from the early 90s that were made in the late 80s. And you look behind the presenter and it looks like this. I mean, if you take the laptops off the desk, it looks like this. The desks are there, but they're all empty. Even in a data center, this is inside the climactic data center, there are not terminals on desks. And if this is the only color one I could find, you'll notice that while there are a few terminals around the place, they're for low-level staff. They're counting machines, they're typewriters, and the 2 big bosses are on the phone, and maybe they've got a calculator. And early on in my career, I ran into these guys. So March the 10th, 1992, they launched Windows 3.0. I was really surprised to find they only sold 3 million copies of Windows 3.0. I thought it'd be way higher. So, oh crap, it still does that. Okay, sorry. Right. So when Bill Gates said a PC on every desk, I was the epitome of the Windows fanboy. I rolled out Windows to some very large corporations on the back of basically me haranguing executives to do it. And even I didn't think in 1992 that he meant a PC on every desktop, like right now, like in 5 or 8 years' time. And yet by the end of the 90s, buoyed on with a little bit of help from Intel, from something called Frame Relay, which was like an early version of the internet for big companies, and Y2K budgets, every desk and every white-collar worker in America looked like this. I mean, to give you an example, in 1993, I worked for Goldman Sachs. I started in March 93 at this revolutionary building in London, in Fleet Street. It was the first major office building in Europe built to have an average of 1 computer per desk on it. And when I joined, they're like, do you know this building is revolutionary? And yet in 8 short years, we ended up with this. And if you look at the data, this is a chart from 15 years ago. So before we had iPhones and stuff. If you look, the only thing that's comparable to the PC until the PC turned up was TV. And the PC turned up way earlier. And even mobile phones and internet, and I imagine if you see iPhone or Steve Jobs' leg bones, I mean, like, they've taken off even shorter, but like the gap between this is a really life-changing event. And we think that TV, PC, internet, and cloud are all things of equal impact on our lives. And the point of this graph is that the rate of technical change can surprise us. Even the people who really fervently believe in it, suddenly one day it all comes together and it hits us. And that's all that I want to tell you about my Big Co time. was that it surprised even me how quickly this stuff happened. One day we're writing memos, and then the next day we're sending emails around the world with 100,000 other users on an email network. When what we're now calling the first bubble, I was talking about this morning actually, in the 90s before the first bubble hit, the previous one was called the crash, and then the 90s thing was called the bubble, and we're now calling it the first bubble, like World War One. So in World War Bubble One, I've been wanting to get back into startups, and part of, by the way, Christian told me to weave into this is why we did a startup, what led to it, and so having done my own little business, I was really keen to go back, but I didn't get it. And I'd meet these people in London who said, we're going to sell dog food over the internet to people in Africa who are vegetarians or something like this. And I'd be like, well, how's that going to work? And they go, well, we've raised the money. You're the CTO. You figure that out. And I didn't get it. I really didn't get it. And when the bubble popped, suddenly I got it. I knew what to do. And I went off and I did 2 turnarounds for British Telecom, and then went on to do 2 other startups that were fast growth. And all 4 of them, I didn't realize at the time, all 4 of them were greatly impacted by something now known as big data. So, history lesson, kids. Back in 2000, big data meant some of this and a whole lot of this, particularly the big stack of cash in the middle and the complicated data centers. And it was hard to describe just how challenging it was. The best way to describe it is our COO, Peter Adams. He started an analytics company in 1998 called Primary Knowledge, funded by Oak Ventures, who were like the Sequoia of the time. And they bought Oracle Parallel Cluster, I think it was called Parallel Cluster. It was meant to be the world's first production parallel database that wasn't like on a Cray. And this thing didn't work. They couldn't get it to work. And anyone who's ever administered an Oracle box, you get these packs of floppy disks. Floppy disks are what computer programs used to come on before the internet. And you'd have to apply these in the exact right order. And finally, they shut the business down, returned some money to investors, which was actually good luck because it was like 6 months before the crash. And then as they're literally emptying the office, a courier turns up with the patch from Oracle that would fix this. It was really, really hard to do anything in parallel. And then these kids from Google came along. Now, without going into all the technical side of it, the really important thing here is when you want to do more in this kind of architecture, these don't get bigger. This number gets bigger. And that might seem like a really, really simple change, but it made scale compute tenable for the first time. And I remember competing with Google. I was CTO at the search engine that powered MSN, as it was called then. This was pre-Bing. And we used to compete on minimum payments we'd offer you. We'd actually literally monetize the user. We'd give you the search engine for free and share the revenue. And I remember the day Google came in with a minimum that was like 15x what we offered. It wasn't like 2x or 50% more, it was 15x. And we're like, how could they do this? Well, they had a plan that included crawling the whole of the internet. And you can draw these lines that just predict the future. And already by 2002, 2003, it was really obvious that crawling the whole internet was going to be really tough. 100 petabytes. And Google didn't just figure out that they could do this, they figured out they could do it economically. And they did it using this stuff. This is a commodity PC. This is in the Microcomputer Museum in Mountain View, which is well worth a visit if you ever find it open. It's fueled by donations, so it's not open all the time, unfortunately. But this is like pride of place. This is like their first rack. And by going back to that, if I can get it back up, by going back to this architecture, they figured out that crawling the web was a definable thing for the future, and that was definable by cost. So by cracking this scalable architecture problem, they had figured out they could go after a big business. And the proof of the pudding is in the eating. So some people would argue, by the way, I'm not sure if everyone saw it, but they were briefly the most valuable company in the world recently. And I have a standing bet with a friend who said that they go to 0 before they go to 1,000. And so we made that bet in 2005 when they went public. So I'm going to claim that dinner, I think, in the next year or two. So Google did 2 things that's interesting here. One is they did something that wasn't easy. They were the first to really do commodity-based scale compute. Other people invented that architecture. Other people invented the PC. They were the first to put it together to try and solve a really non-trivial problem. But they also benefited from these 2 guys. So who knows these 2 guys? Come on, they're one that's famous locally. So, right, Brad Feld and Gene Kim. Gene Kim's one of the founders at Tripwire. They studied together in the 90s. I didn't know this. There's a great blog post that Brad Feld put out a few years ago. They figured out that they were trying to solve this idea. They wanted to quit school and go do a startup, and they both did. But they were looking at the macro conditions for these startups, and they wanted to do a video startup. And Brad and Gene figured out that one of the constraining factors was the availability of bandwidth. So they went back through time and looked at the rate at which the average modem speed in the United States was progressing. And they predicted that they thought they needed about 1.5 megabits of bandwidth to do a video startup. And they predicted that that would happen at the beginning of 2005, which is plus or minus 6 months when YouTube got bought for $1.4 billion. They also predicted Napster based on similar things. And it's a pretty simple rule. And they published this stuff in the 90s on early blogs to predict. They didn't say Napster's going to come, YouTube's going to come. They said these things are changing. And so in my world, I think there's two things you can do as a startup. You can do something that's hard, or you can do something that was hard and has become easy, and you can do it well and quickly. And to me, Google did. Oh, I lost the connection. To me, Google did both. But more importantly, the legacy is they put in place some blocks that allowed cloud computing to finally happen. Sun were the first to produce a commercial thing that's the nearest to the cloud as we know it. They called it grid computing. And at the time, just some of this stuff wasn't ready. It was too vendor specific. And if you think about it, and I'm being really simplistic here, so please don't pick me up on it's not really that simple. But you've got, before you put all your money into vendors and hardware, and you scaled up. You made a bigger and bigger rack cluster. And after you could do it with free software, commodity hardware, you scaled out, and the money goes into your people instead of your vendors. And that will come more important lately. But basically, thank you, Google, for making scale computing viable, possible, even tenable. So next step, big cloud. So we've got big corp talk about how quickly technology happens. Big data talks about putting in place things that are needed, enabling technologies. So now big cloud. So it's 2010, and I've got a problem on my hands. So these are actually 3 different children. They're my 3 kids at the same age. So I remember posting this picture on Facebook and people being surprised to find out that was 3 different children. So my wife and I both come from very large families. We put in thousands of hours of babysitting time, and we confidently expected to cash it all in when we had kids, and we find ourselves living in Kansas City with no help at all. And my wife unilaterally announced that she was going back to Oregon where she grew up, and I thought it'd be nice to see the children at least from time to time, so I followed. And I'm being flippant there, but so I find myself in Portland, and I'm focusing on doing a big data startup. Now, my previous company had not found building big data that straightforward, and was a big data company. It was a behavioral targeting company. One of my co-founders, John, is sitting up here at the front. He came and worked with me there. He'll tell you some war stories, but just put it this way: when the data center burnt down, the chief clown who built the center couldn't attend the investigation because it turned out he'd moved to Africa without telling us. And now he couldn't come back because the IRS would garnish his wages. So I was general manager of a division. I had to figure out how to get my data. And with great reluctance, in early 2008, we turned to the cloud, kind of out of desperation. And what's really interesting there is my network guy went on to found a company called Evident, but not before he was the chief architect moving Adobe onto Creative Cloud. And our engineer, the guy who made it really possible to do Hadoop, a guy called Florian Liebert, and he went on to found Mesosphere. So as a leading light in the Mesos community. So it's funny, we had this little cluster of us in Kansas City desperately trying to deal with burnt data centers. But that led me in an unusual place to have an early insight into the cloud. Now, you might not be able to read this, but this is a blog post I published in December of 2008, in which I predicted that Cisco, IBM, HP should get their act together before Microsoft, Google, and Amazon eat their lunch by leasing out their clouds to the world. And this is before Microsoft or Google actually had a cloud. And to me, it was the inevitability of this trend that led me to do some cloud consultancy. I could talk to it with some confidence And I help some of my clients get on the cloud, and they hit this problem, an uncontrolled cloud deployment. So you can spend an awful lot of money very quickly when you're not paying attention to this. And all of the IT cost controls are all about upfront spending. You have to beg on your knees in front of the CFO. You spend 9 months planning this giant capital deployment. Everyone gets buy-in and alignment. Meanwhile, the system's kind of gently browning out. People are having to do a bit of extra overtime, but it's all under control. You pay for the money up front. With the cloud, you've ever seen a building or a bridge built on time and on budget? No, because engineers like to build stuff. And now you've given them an infinite Lego set. They go out, and as soon as they get the hang of it, you get this kind of uncontrolled deployment. As soon as the spending gets to a certain level, all hell breaks loose. I built Cloudability as a fire hose to douse those concerns. I didn't build it as my big startup. It was my customers. I didn't want to bill them $400 every time they ran me up and said, how much are we spending? And it was taking a lot of my time. So I built this daily email. This is actually from a screen cap of one of my customers. And I'm sending this stuff out, and one day it breaks. And my God, all hell broke loose. I was busy doing some other stuff. This was a courtesy, and I didn't understand just what was going on. And when I dug into it, I found some very interesting things. First of all, by the way, this is not a pitch for our business. This is a pitch for cloud. First of all, I found out that my customers were using cloud for a different reason that I was using. I was using it because I was desperate. If there was anything I could have done cloud, I would have done it, but I couldn't. My customers, this is now 2010, not 2008, were using it to go faster. And when my email stopped, the lights went out. I literally had one CEO trying to see me. She said, I'm sure it's in your contract. You have to do this. This email was getting forwarded. This one little email. I won't go back. Yes, it does. Oh, it's a bit slow. Sorry. This one little email was getting forwarded all around the org. And when it disappeared, people were getting very nervous. So I wondered, well, what's going on here? Well, it turns out that business people are actually pretty smart at spending money. 96 cents in every dollar spent by American businesses is spent by non-IT guys. And you know that they're good because de facto the ones that are bad go bust. So only 4% are spent by IT guys. And when you get it right, that you can kind of spend at a quicker rate and do things at a quicker rate, great things happen. This is slightly out of date. Netflix launched in 43 countries. Well, they launched in 130 in the same week. So I should update that slide. But meanwhile, HBO, trying to build this stuff out in their data center, were thinking about offering a Friday night pass to get you access. If you're really good, you have HBO++, you pay extra, you get access to your TV shows a bit early. So one company is struggling to deal with domestic demand. The other company is going after global TV and putting their app into every single television set. One of them is struggling with the basic technology. The other one has outsourced that to a whole bunch of companies and is just so much more agile and faster. And I've got a bunch of other slides of like Romney versus Obama, all sorts of people who show this for the early adopters. Unfortunately, you got to know your stuff to do this right, and it's still early days, okay? And what people are really looking for is something we call big cloud. And basically is everyone gets whatever they want whenever they want it. You go from an ask for forgiveness, ask for permission model to an ask for forgiveness model. And yet you're still in control. You have insight, you have hard data, and this is almost like a FinOps role. And this is very similar to something else that we've seen called supply chain management, and we'll come to that in a second. If you don't do it, it breaks everything. And this is why we formed a startup. And if you want to see Obama going grey in 7 years, well, that's what 5 years at a startup does. John's down here, I'm up there. So
that is, in fact, me on the left.
Yeah, that's John with the orange hair. So we had our new color palette, and he was wearing the blues and the oranges, and it really suited you.
Jen won't let me finish my word you did all them on Facebook.
So if we think about this in the long term, then we have to do a little bit of a history lesson. And bear with me on this, because I think for me, when we really thought about this and why I did the startup, there's some very profound forces at work. If you don't remember your history, you're doomed to repeat it. And if it's going to repeat, then I want a Tyrannosaurus Rex. But more seriously, if we go back to the beginning, we can go back further, but if we go back to 1930s, on the left is Henry Ford, first guy to think about mass production with the same things. He was famous for going through scrap heaps, looking for the one part in a Ford that didn't break, and he found a split pin that was always there, and he told them to make it cheaper. And that wasn't because he was a scam artist trying to rip you off and make you pay for replacements, because it was over-engineered, and here was a way to make the car a little bit cheaper, a little bit more efficient. But what we're going to talk about, the Japanese. So the Japanese came late to the Industrial Revolution, about 1868, the Meiji Restoration, I think. Suddenly, they wanted to catch up. And they're a little tiny island with not many resources and a lot of stuff to learn. And they were buying a lot of stuff from overseas, train engines, gearboxes, things like this. So the Japanese government introduced, first, it was a tax credit for know-how. So instead of just putting money into a supplier, you could put know-how and claim that as an R&D credit. Well, if I've got some special process, I'm not going to give it to anybody. I'm only going to give it to someone I went to school with, or who's in my family, and that person, I'm going to be their biggest customer, so they build the factory next door to me, and instead of building a whole lot of stuff and shipping it once a month, they're going to take yesterday's orders and ship them today. And Kanban wasn't invented that way. There's a very neat story about how they limited the number of visitors to the Imperial Gardens, but it was a really good way of summing up this very, very closely knit relationships between Japanese manufacturers and their suppliers. Interrupted by World War II. Now, as a Brit who has parents who were alive during World War II, and the British industrial might that they started World War II with, I've always found the American war statistics shocking. And all you need to know about these graphs is there's like 20 of them, and in every graph there's a spike, which is America, from a standing start from 5th or 6th, outproducing all other countries put together in the world. And a key part of this was repurposing. Sherman tanks were being destroyed by Panther tanks because they had Ford motor car engines in them. They'd overheat. They weren't designed to move a tank around. But because you're repurposing something you're already making, you had a lot more of them. And guess what? You got gradually better and better and better. And the amount of war material that came out of the United States is absolutely staggering. For the purpose of this talk, the world discovered that lots of something that's kind of commodity is better than a little bit of stuff that's perfectly suited. And another thought pattern that came out of the war and during the Cold War was shared infrastructure. Before the war, every plant would run its own power units, and the power guys would have veto over what you ran on the manufacturing line. Because if you ran the wrong equipment, you could blow up the power plant. Ring any bells yet? IT guys? So after the war, the best IT guys went off to work for General Electric to build nuclear power stations and very large grids, and everyone else had to find another job because now you could have power everywhere. But again, the mentality of commodity products, shared infrastructure, drives the modern consumer, which in turn drives a tremendous amount of logistical complexity. I was really surprised to find out that barcodes were invented in the 50s, and that containerization was a response to this. So you've got this kind of feedback loop now. You've got all this infrastructure, you've got this capability, you've got this demand, it's driving complexity, you solve the complexity. Well, it's also driving the Japanese recovery after the war. So we come back to the Japanese with their very tight business relationships. They're making a lot of stuff that's getting sold in the US, and eventually they recover to the point where the fundamental fact that they're a little tiny island with no resources is coming back to be a struggle for them. And it's expressed as an exchange rate problem. And they had to figure out how to buy cheaper things from cheaper locales, which was a challenge because they're used to only working with people who were next door, same language, same culture. And in particular, the guy who picked who to work with was known as the CEO because the relationships were that difficult. And this was a difficult model to scale. Well, Toyota had a go. They called this thing called the TQMS. And by the way, there's another thing Japanese industry was very keen on called Kaizen, which is continuous improvement instead of radical changes. They would always be getting better. The TQMS pulled two of these things together and allowed anyone to come and work for Toyota if they met basic criteria and committed within 2 years to meet elevated criteria. So this very dry document unleashed this global supply chain just in time for inflation. Inflation was very tough for Japan, and it made them go really into accelerating this global supply chain thing. And lo and behold, in 1980, Japan overtakes America making cars. Now, today you don't think much of that, but at the time, Americans owned one car for 1.7 people. Japan owned one car for every 12 people, and they're out manufacturing the US. What happened here? Comparative advantage. Now, if you Google comparative advantage, it's a theory produced 200 years ago by an economist called Ricardo. I couldn't find a single video that didn't make me go to sleep. So I'm going to try and do it. And again, I'm rounding some corners here. I'm making this as simple as possible because it's actually a pretty boring topic. So if you think about Russia and Scotland, they can make oil or whiskey. Obviously, Russia's better at making oil than Scotland. Scotland's better at making whiskey than Russia. If they make a bit of everything, so they don't have to do any imports or exports, i.e. they do it all themselves, you'll see that I've done a half here. Then Russia makes $80, Scotland makes $145, world output is $225. If Russia makes just oil and Scotland makes just whiskey, global output's up 50%, and then they trade whiskey for oil. That's comparative advantage. It's do the things that you are the best at and buy the things that you're not. So in pictures, if you switch out oil and whiskey for like Linux and Go, all right, don't install servers when you're actually better at writing script. And that's the force that's going on here. That is why Japan, oh, sorry, I missed a slide there. That's why Japan were outputting 4 times as many cars per worker as American manufacturers, because they'd mastered the complexity of the supply chain, they'd mastered the scaling of relationships, they were able to take comparative advantage, they were able to buy from wherever the goods were the most efficiently produced. And this was a sharp shock to the US. People caught up with it fairly quickly, and the result is a car in the US, a $30,000 family sedan, costs the same today in inflation-adjusted terms as it did 20 years ago. And yet it has double the mileage, it has a 100,000-mile powertrain warranty, road deaths are at a 60-year low per miles driven, and every car has Bluetooth, air conditioning, and look at the wheels. When you leave here tonight, try and find 2 vehicles with the same set of wheels on. We are making wheels at a third of the cost we were 20 years ago, and you can have them any color or size you want. They've just got to be round. So, getting to the end of this lecture now, this kind of supply chain is starting to hit electronics, and then Dell starts making PCs by just buying up the cheapest parts, and now they don't even make the PCs, they just assemble for them, and I think they've sold their division to some Chinese firm now, but because they're focusing on the stuff that's the most valuable. Oh, that went the wrong way, sorry. And then this supply chain hits software, and it's collided with people like Google and others making scalable software very doable. And it's happening like Windows, like internet, like TV, quicker than people are expecting. By the way, I love this slide. If any of you are journalists, I'm sorry. So this is the front of Business Week saying, yeah, Amazon selling cloud services, you've got to be kidding me. So what? What does it mean for us? This is a graph of Microsoft's revenue. In 1995, they crossed $5 billion in revenue. That was the first time they offered me a job, and I turned it down because their stock had doubled. There was no way it was going to double again. Well, it doubled 2 more times. And Amazon I think we're just about here. It feels like the mid-90s. Like Windows 95 was a big hit. Windows 95 sold 40 million copies versus Windows 3 sold 3 million copies. And it became mainstream, but it still wasn't like the industrial strength stuff. So there's a tipping point, and I think we're on it. We're seeing it in our customers, the rate that they're spending. And I talk about it this way. This is not my invention. This is a very standard adoption curve. We think this is a very standard adoption. It's hindered by humans learning new things, giving up old habits and tools, maturing. But we've seen the innovators and the early adopters in. We're now seeing the early majority. We meet companies sometimes who go, my bank balance keeps going up. Why do I need Quicken? I'll buy it when the bank balance starts going down. We see that a lot in the majority now. And we're also seeing the early guys start to stop looking at the cloud as a data center, but as a service center. So instead of running a mail server, buy a mail service and more sophisticated versions of that. So something that wasn't so easy is now easy. Thank you, Google. We've got some very, very long-term trends at work here. And I hate to use the word paradigm shift, but I couldn't find anything to describe it more accurately. So remember, less Scotch and oil and more Go and Linux. And last, I can send you a snapshot, John. So rather than me keep talking, I've made 10 predictions here, like I did in 08. If you wanted me to ask me about one of them, then put up your hand. We'll throw you the mic and we'll discuss it if you find it interesting. Of course, if you've got a question, then please put that. But that's the end of the talky bit of my lecture.